Wow, look at this. I'm writing the month 11. Wow. It's November. Woo. Guys got so quiet. This next little miniature unit will come at you in two parts. We'll spend a couple days on absolute value equations. They're pretty straightforward. And then the more tricky ones are the absolute value inequalities. There's not much I can do to get in the way of the difficulty of inequalities. I sure try hard, but the equations, you shouldn't really struggle today. The note should take 15, 20 minutes, and then I got a worksheet for you. But yeah, enjoy the couple days here while we do this, and then just know that like on Wednesday when we start inequalities, if we do, I might do a separate quiz, but when we start that, just kind of step up your mind game a little bit because they get a little trickier, a lot trickier. Like on the scale of 1 to 10, today's like a 2, and then inequalities jump to like an 8. So you kind of think, oh, it's just more absolute value stuff. Don't generalize it like that because they're not in the same difficulty bracket. So let's start with a basic equation. The absolute value. Are you guys all familiar with what this is? Like, do you guys, let me just, I hadn't intended this to be part of the notes. Yeah, let's just make sure. Again, I'm going off the script here. I'm just want to make sure that we're all familiar with like what this means. What does it mean? That's not what it means. That's what it equals. Here, I'll just write that down. Say that again. Yes. You must fundamentally remember that the absolute value of a number is its distance from zero on the number line. So we have to think in two different directions when we get to the equations. Because if I said to you that I'm thinking of a number whose distance from zero is 5, then you understand that it could be one of two things, right? It could be -5 because that's 5 that way, or it could be +5 because it's 5 that way. But let's just make sure we're good. So if I said the absolute value of -5, you go, oh, it's 5 units away from zero. And there you go. What you really want to stay away from in this unit coming up the next couple of weeks is the ghetto definition of absolute value, which is that if it's negative, make it positive. Um, Someone hopefully would have yelled at you for that kind of thinking. It is true that when it comes to just a basic problem like the absolute value of 4, you could get by for a long time with that ghetto understanding that if it's negative, ooh, I'll make it positive. And if it's positive, ooh, I'll leave it alone. But we don't want to rely on that. As we go forward, we really want to think about distance from zero. It's what opens up understanding for the next couple weeks. Okay. So there are three things that can happen when I ask you to do an absolute value. I can ask you for the absolute value of a negative number. I can ask you for the absolute value of a positive number, or of course, I can ask you for the absolute value of zero. Those are the only three types of numbers really that we're going to talk about: negatives, positives, and the neutral guy, zero. Okay. So having said that, let's get down to fundamentals. If I wrote an equation up here and said I'm thinking of a number x, and his absolute value is 3. What would you think? Yeah, I mean, the obvious answer is that x has to equal 3, right? But again, that's not done. X could also equal -3. So when you're given an absolute value equation, you have to write two separate equations stating the possibilities. One of those possibilities is that x could equal 3. The other possibility is that, oh, x could also equal -3. So you're going to see that these equations will have often more often than not, two solutions because whatever's inside the absolute value can take on two different things. We would agree that if we replace the x with a 3, this would be a true statement. And if we replaced it with a -3, this would also be a true statement, right? Okay. What if I told you I'm thinking of a number m and his absolute value is 0? What would you say? We have to be thinking in terms of what M is. And there's only one thing that M could be, and it is 0. This would be an instance in which I don't have to think of it in terms of two solutions, because there's only one number that has an absolute value of 0, and that is 0. And then finally, before we get into how to actually do what we're doing today, what if I gave you an absolute value and I said, okay, I'm thinking of a number y, and his absolute value is -2. Your job is to find me a number y that if I replaced him with that number, that statement would be true. Did you find it yet? Come on, slowpokes.
Y.
Nope. Tell me something about distance. When you measure a distance, what will it never be? Negative. I could measure a distance and say it's 0. Like, what's the distance between my two fingertips? It's 0. They're touching. Or I could say, what's the distance from me to Dallin? And it's 9 feet. What's the distance from Dallin to me? It's 9 feet. We don't measure distances in forwards and backwards. There are no negative distances. No one in their right mind says the distance from here to Denver is -104 miles, right? The distance, whether you're coming from Denver up to us or us down to Denver, is 104 miles, correct? Having said that, distance can never be negative. Therefore, this particular equation has no solution. These are the three situations that you're going to be faced with. You're going to be faced with absolute values that equal a positive and require two solutions, absolute values that equal 0 and require only one, and absolute values that try to equal a negative distance and can't be solved. Okay? Do you understand that? Okay. So let's actually solve an equation now. Let's take a look at this one and say, okay, what if the absolute value, I'm thinking of a number x, bless you, and if I add 5 to it, the absolute value of that quantity is 2. If I took my yellow pen and I scribbled this out, and I know you just wrote it down, so you know, like, spoiler alert, but let's say you couldn't see what was under my yellow. What could you tell me about what's under my yellow? What's under there? Okay, good. So we would all agree that whatever's hiding under the yellow mess either equals 2 or it equals -2. We agree?
Yep.
Okay. Therefore, we can say that x plus 5 maybe equals 2. But we have to write a second equation understanding that whatever's under there, well, it's not there anymore. X plus 5 could potentially also equal -2. It's that cream filling, the stuff in between the wafer cookies, right? That stuff in the middle is what we're focused on. We control the situation and say, I need whatever you are to equal one of these two values. And what happens then is usually what pops out are a couple of little 7th grade math problems, 2 of them. Like, take a look at the red one. How would you solve it? How would you solve this little red equation? That's not how you would solve it, but I agree that the answer is x equals -3. Like, go back in the old days, we would just subtract 5 from both sides, right? So one of the answers to this problem is that maybe x equals -3. If you don't buy it, check it yourself. Go right up here where this yellow arrow is and change that into -3. What's -3 plus 5? 2. And the absolute value checks out. But we also have to acknowledge the purple one and say, okay, well, what makes x plus 5 equal -2? Subtract 5 from both sides, what would x have to be? And again, it's good. It feels good to check it because it's like, I don't know if that's how we would have thought initially, but going into it now, I'm like, I want to make sure that that number is legit. So again, go back up to where the yellow arrow is and change it into our second number, -7. What's -7 plus 5? -2, which is exactly what we want, because the absolute value of that would also equal 2. So this is an absolute value equation, as most of them are, that has two different solutions. Kind of like quadratics, but for a different reason. Let's go again. The absolute value of -2x minus 3 equals 1. What you wind up doing, you're going to hear this word. I mean, this is probably an exaggeration, but you're going to hear me say this word probably 300 or 400 times in the next couple of weeks, and it's split. The word split is going to be really handy for us, because what we find ourselves doing is splitting this unsolvable equation. That is not solvable, but it will produce two equations that are. So we're going to split into two. What's one of the equations that we'll create? It's all about the cream filling, this stuff. What do I want that yellow egg to equal? I want it to equal 1. I'll figure out what x is later. But for now, I take control of the situation and say -2x minus 3. Whoever you are, you cryptic little weirdo, I need you to do me a favor and make yourself equal 1, because that's a fact. If the original equation is a fact, then the red equation has to be a fact. But I have a second situation, don't I? What else could the yellow egg force himself to equal? -1. So stuff inside -2x minus 3, maybe you equal -1. We're creating two truthful situations. Note that when I split, I take off the absolute value. Sometimes I do a poor job of teaching this, and then I see kids leave the absolute values on, like I'm going to do it in green. This is so wrong that I'm not allowed to use the word I want to use to describe how catastrophically ghetto wrong that is. The whole point is that we're taking an unsolvable absolute value equation and creating two solvable equations by removing the absolute value from the picture, right? Help me solve this red one over here. What would I do to both sides? This one. Do we need a review on 7th grade linear equations, or you just don't want to talk to me on this Monday? Are you have a candy hangover or something? We would add 3 to both sides first, right? Equation solving 101. Plus 3 gives us -2x equals 1 plus 3 is 4. And what would we do last? Divide by -2, giving us x equals -2. If this were an Algebra 1 class and it were like the middle of September, I would require you to show your cute little plus 3 on both sides and your cute little divided by -2 on both sides. I assume most of us have probably gone past that phase of our learning, but if you're still comfortable showing all your steps, that's fine. I won't hold you to account for that in November of Algebra 2, but that's what we're doing. How about the yellow equation? What would I do? Or the purple one, excuse me. What would I do first to solve it? Add 3, giving me -2x equals what? -1 plus 3 is 2. Divide both sides by -2. What does x equal? What is it? No. Yeah, -1. And it's always a good idea, before you put a box around these answers, just to take a quick moment of your time, go back up here where the yellow arrow is, and just change it into what you claim you think it is. One of our answers we think is -2. So kind of follow where I'm moving my pen here. What's -2 times -2? 4. And what's 4 minus 3? And the absolute value of 1 checks out. And then again, follow my pen up here. The other answer that we think is -1. What's -2 times -1? And what's 2 minus 3? And the absolute value of -1 equals 1. It checks out. I personally wouldn't box up my answers until I've taken a quick moment to verify them, but you certainly don't have to do that. It gets harder to do as the problems get more complex, but still, It's your right. That's what I've always said about factoring. Is like you should never turn in a factoring test and go, I'm not sure if this is right. You should, because you can multiply it back out. That's kind of how I feel about this. Let's go again. The absolute value of x over 4 plus 7 equals -4. What do we do? Good. And I never know in this part of the lesson from one year to the next who's going to say it. My Usually what I find is that we're at that perfect point of the lesson where people say, let's write two equations. Let's split it just like we did on the first example and the second example. Good job. Good spot, Will. Don't forget the absolute value of no matter what. I could have written anything in that red egg, anything. And this problem is literally impossible to solve because the absolute value, this can never equal a negative distance. Therefore, again, good job, Will. This problem has no solution. If you try to solve it, you're going to lose points. All right? It's impossible. Nice catch. All right, let's go again. The absolute value of 4x plus 1 equals 0. ¿Cuántas ecuaciones necesitamos? How many equations do we need? Only one in this case, because going back to the very top of your notes, you'll recall that one of the possible scenarios is that you have an absolute value of blah, blah, blah equaling 0. What's the only number in the world that I could replace that yellow egg with to make this true? 0. Therefore, only one equation is required in this case. Do not write two, because you'd be saying like equals 0 and equals -0. And that's just weird. So we're just going to simply say cream filling stuff, 4x plus 1. I just need you to do one job for me. I need you to help me reveal what value of x would make you equal 0. Okay. And then again, it always boils down to just your basics. What do you do to solve this equation first? Subtract the 1, giving you 4x equals -1. And next, dividing by 4 gives you x equals what? I hear it all the time in algebra 2. It doesn't matter what class I'm teaching. It just doesn't matter. People always say, well, I don't know what to do because I can't divide 1 by 4. And as I've been preaching to you for years, if you encounter two numbers that can't divide, you leave it as a fraction. Therefore, the only solution to this equation is -1/4. And if you want to vet it, it does get harder up here where the yellow arrow is. If your basic skills are ghetto-y, then you're going to have a hard time with this. But what is 4 times -1/4? -1 plus 1 is 0. So you've seen now all three types of equations. You've seen the type where you split into two, solve. You've seen the type where you just throw in the towel early and say, no can do, no solution. And you've seen the type where now you say there's just one equation. Okay, now we're going to go a little bit deeper and then we'll be done. Follow your instincts on this one. You obviously spot that there's a new guy, right? There's an intruder in our peaceful little process. Who is it? Follow your math instincts. What do you think we ought to do? Nope. Nope. Absolute values you don't want to distribute. They're not parentheses. Good instincts, but no. What do you mean? I'm going to say this for the first of about 184 times, so here it goes. This thing in the gold box, the yellow box, is called the absolute value. And I know you know that, but your battle cry for the next 2 weeks, I'm going to write this down so that you can too, Job one, primary job, get that by itself. All the stuff we're talking about today has no relevance until that is by itself, until I can identify what the absolute value is trying to equal. And I understand why you'd want to say no solution because there's a negative 24 on the right. Hmm? But I mean, just think of the situation. Like if I gave you something similar like this, if I said negative 3 times something equals negative 24, right? What would you do? Just look at the red equation. Say again? Correct. So that's what we're going to do here is we're essentially now going to just work around. We're going to treat that yellow box like a brick. Just you sit still while I clear all the stuff away from you. So I'm going to take both sides now and I'm going to divide, and I'm going to show my work this time. I'm going to divide both sides by negative 3. What that does is it gets rid of the negative 3 over here on the left, and I bring down my absolute value of x minus 8. What does it now equal? So what looked like a no solution problem 30 seconds ago, we now realize is in play. And from here, we would use the S word, split, split, split. So you're going to write two equations. Equation number one will say stuff inside the absolute value. I need you to try to equal 8. The other equation is going to say, hey, stuff inside the absolute value. I need you to also try to equal negative 8. Those are the two possible situations that are going to get us through. The equations that result should never be the struggle. Like from here, you just add 8 to both sides. What's the purple answer? 16. What's the green answer? And there you go. Not a bad idea to check them. Go back up to the top. I'll use a red circle up here. It's more of a red oval. Change that into 16 real quick. What is 16 minus 8? 8. What's the absolute value of 8? 8. What's negative 3 times 8? 4. He can have a check mark. Do it with 0. Go back up to where the red egg is at. Put in a 0. What is 0 minus 8? Negative 8. What's the absolute value of negative 8? 8. And what's negative 3 times 8? Check. Never a bad idea to check your answers before you hit send. All right. Let's step it up one more notch. Let's do negative 2 plus 6 times the absolute value of 2x plus 4 equals 16. I have been attempting to teach some version of this lesson for decades now, and I am about 90% successful on what I'm about to say. So maybe this will be the year that I hit 100%. Do not add those together. Do not. That's just flipping the middle finger at the order of operations. Just looking at the math gods, thumbing your nose at them and saying, I'll do my own order of operations. I'll do what I want. You know better. So we don't have any like terms. Tell me this, if I gave you an equation that said this, negative 2 plus 6y equals 16. We've done enough of this in our time together. Don't you dare try to tell me that you would try to add negative 2 and 6. Would you? No way. What would you do in the red equation? What would you do in the red equation? I'm sorry, what? No, you're hurting my heart. We would get rid of this by adding 2 to both sides, right? We know how to solve equations. We undo the plus or minus first. We undo the times or divide last. So in this equation, we would be left with 6 times the thing we're trying to get by itself equals 18. I see no reason to treat this white equation any differently. So we are going to come over here and we're going to add 2 to both sides. Don't you dare think that these are like terms. The 6 is multiplied by something. He's not just out in the open waiting to be added willy-nilly. If I add 2 to both sides, I'm left with my 6 still multiplied by the thing I'm trying to get by itself. And 16 plus 2 is 18. And we find ourselves back where we were in the last problem. What do we do to both sides? We divide both sides by 6, like this. And that'll give us the absolute value of 2x plus 4 equals 3. This is go time. It's probably not what I don't think I've ever written that. 30 years of teaching, I've literally never written go time in my notes before. That just happened. This is the moment where you make a choice. Do I split this into 2 equations? Do I write 1 equation, or do I write no solution? Which one is this? Say again? Definitely 2 equations. There are 2 things that equal 3 if you take their absolute value. One of them is -3. The other one is +3. The order in which you write those red and green equations doesn't matter. You just need to account for them both. The possibilities that the cream filling could equal 3 or the cream filling could equal -3. That's where the split occurs. The split does not occur at any point before that. Until you get the absolute value by itself, no splitsies. Now, let's solve. Red equation. What do you do to both sides? Subtract 4, giving you 2x equals, what's -3 minus 4? -7. Divide both sides by 2, resulting in a fraction of -7 over 2, -7 halves. How about the green equation? What do we do to both sides? Subtract 4. The mechanics that you use to solve your little offspring equations, they're always going to be identical mechanics, because the business side of the equation is always going to be the same. So we subtract 4, giving us 3 minus 4 is -1. Divide by 2, giving us x equals -1/2. And again, they do get harder to check, but in the interest of time, I'm going to not do that with you this time. But you could plug them back up into the beginning of the problem and be like, oh, it actually works. It's kind of cool. Ready to go again? Let's do 12 minus 4 times the absolute value of 3x minus 7 equals 20. What do we do first? Yes. Remember, do not do 12 minus 4. Oy, boy. Get rid of this positive 12 by subtracting 12. And again, I'm showing a little bit more work at this point just to make sure that we're all clear with what we're doing. That means I bring down the -4. He used to be called a minus. Now he's called a negative because the whatever was in front of him got taken out. So now he's -4 times the thing I'm trying to get by itself equals, what's 20 minus 12? 8. We're looking good, but we're not there yet because we don't have the absolute value by itself. What do we do next? We divide both sides by -4. And at this point, this is go time. This is what I call the crossroads. This is the point where you stop and you make a decision. Which way am I going to go? Am I going to write 1 equation, 2 equations, or am I going to write no solution? Let's find out. We're going to get the absolute value of 3x minus 7 equals -2. That is an impossibility. Therefore, there is no solution. I have 2 more examples and they each serve a purpose. So I know you're probably ready to be done with me. As always, these notes took way longer than I did. Somebody just fart? Nice. Did I hear that correctly? Someone just a little toot? Why do I record stuff like this? I'm such an idiot. Send me a little squeaker? Little whoop. Well, just asking. You got to do what you got to do. Let's do 10 minus the absolute value of negative x minus 5. I wasn't trying to start a witch hunt. I was merely curious if someone just had a little tootsie. It's not a crime. This problem serves the purpose of trying to dispel the teenage myth when people say there's quote unquote no number right there. And I just go, oy. And we talk about this in Algebra 1 a lot. Is there a number right there? Yes, there is, right? We don't, math people don't write ones like that. Just know that he's there. Don't think this situation is any different. Don't say something stupid like I'm going to divide both sides by 10. Why is this any different? If there were a -2, you wouldn't do that. If there were a -4, you wouldn't do that. Do mechanically what you know you're supposed to do, and that is eliminate a positive 10 by subtracting 10. Don't abandon what you know just because of an invisible one. The tens disappear, and I'm left with now the negative of the absolute value of negative x minus 5. And what's 1 minus 10? Oh, yeah. Are we ready to do the old crossroads? So what do we do? Yeah, divide both sides by a negative or -1. It doesn't matter what you call it. At this point, I would just divide both sides by a negative. And this is going to now allow me to make the decision. We make no decisions prior to what we're about to see. What the number is on the right has no relevance until we accomplish our initial objective, which is to get the thing by itself. And what is -9 divided by a negative or a -1? +9. So do we proceed? Yes, we do. And since it's a number that's not called 0, we write two equations. It's time for Splitsville. What will one of my equations say? Yeah, that's a possibility. What's the other possibility? That's it. That's what's algebra is not a class, it's a tool. Algebra, if you keep taking math classes, algebra is not something that is a class. It is a tool. It is a box full of little tools that allow you to manipulate the math. That's all algebra ever was. We used algebra to control a situation, and now we're going to use our basic skills to solve it. Purple equation, what do we do to both sides? We sure do all day. So negative x equals 14. Next step, divide by negative, -1, giving us x equals. Perfect. Red one, add 5. What does negative x equal? -4, divide both sides by a negative. What does x equal? And those are your two solutions. And you might think, I can't believe this man's making me do another one, but I do have one more. And again, it does have a very specific purpose. So bottom line is, in a nutshell, get the absolute value by itself and then make a choice. And it's going to be one of three choices. Splitsville, one equation, no solution. Cut and dry. Last one, guys. -6 plus 3 times the absolute value of 3 minus 4x equals -6. What do we do first? Add that 6. That -6 is the straggler term, so we have to eliminate him first. If I add 6 to both sides like this, I'm left with 3 times the thing I'm trying to get by itself equals, what's -6 plus 6? I'm still not ready to make a choice because there's a clinger. Got 3. It's clinging on, man. How do we get rid of that guy? Divide both sides by 3, giving us the thing we're trying to get by itself, finally by itself, 3, the absolute value of 3 minus 4x equals 0. One equation, two equations, no solution. 1. Remember, you can only equal 0 if you're called 0. Therefore, I just write one equation. Do not solve this equation. No solve. Got it? That is an order. You do not solve an absolute value equation. You create solvable equations. So you must, as annoying as it is, take the bars off and now say that 3 minus 4x equals 0. And now we solve. What do we do to both sides?
Right.
Subtracting 3 gives us negative 4x equals what's 0 minus 3? Divide both sides by negative 4. What does x equal? Boom. I'm going to hand out your assignment. I realize now that my lesson took up pretty much the whole hour. I'm going to hand it out. You're going to see if you can get a problem or two done. I did not leave you a ton of room on the worksheet. I would highly, highly, highly recommend that you use separate paper. Okay? Tomorrow will be a work day.